previous video, we learned how to go over the law of sines, but in this video, I hope to go over how to use the law of cosines instead. And so here are two practice problems, and let's do them. So the first one here, we have all the side lengths for this triangle ABC, and we're trying to find one of the angles. So when we're trying to use the law of cosines, one indicator that we have to use it is that we have all the side lengths. And that's because if we have, let's say, for the first equation here, we have A, B, and C, which are the side lengths, and there's also B here and C here again, then we can just find angle A, and then we can also apply that same logic to find angle B and C. So if we have all three sides, we can use the law of cosines. So let's do that. In this first example here, we have A is equal to 21, B is equal to 18, and C is equal to 14. And we're trying to find the angle C. So that would be the third equation right here. So I plugged that in. We got 14 squared is equal to 21 squared plus 18 squared minus 2 times 21 times 18 times cosine C. When we simplify this, we get 196 is equal to 441 plus 324 minus 756 times cosine C. There are a lot of numbers here, but we keep going and we get that cosine C is equal to this right here. And even if we get a negative number, it's okay, but this whole expression right here should be positive. I think should be positive, yeah. So when we simplify that even more, we kind of have to do the inverse cosine of both sides to get rid of the cosine that's on the left side here. And we finally get that C is equal to inverse cosine of negative 569 over negative 756. And then when we solve that, we get that the measure of angle C, which is x degrees, is around, measure of angle C is around 41.17994 degrees. And so that'll be our answer for number 1 using the law of cosines. For the second question here, we have two sides and their included angle. So if we look back right here, two sides and their included angle would be basically us knowing the entire right side of these equations. Because, for example, let's look at the second one here. We know A and C. If we both know A and C, its included angle would actually be angle B. And so let's replace D, E, and F with kind of A, B, and C here to make it a little bit more clear. So A, B, and C, and this would be temporary if you're solving it. So we have angle A. So if we're using the law of cosines and we have two sides and their included angle, we should use that angle which matches kind of what it is here. So that would be D. So we plug that in, and then I wrote this out. We get x squared, which would be the opposite of D, right? Because if we're saying that D is a replacement for A, then we would say D squared is equal to E squared plus F squared minus 2EF times cosine D. So we have, this is kind of side D. We write x squared is equal to 12 squared plus 19 squared minus 12 times 2 times 19 times cosine of 93 degrees. And then when we write it out and simplify it, we take the square root of both sides, and then we get that the final side length of x is around 22.99707. And so these are the two main cases where you use the law of cosines. It's either when you have all three sides, or you have two sides and their included angle. And just to kind of tie it back into previously, the only time we will use law of sines is if we have a side and angle pair. So for example, if we have this angle A here and 21, if we have this angle B here and 18, we kind of have to have a pair like this to use the law of sines, right? And without that, we can't really use the law of sines. So one reason we couldn't do it for this question is because if we're trying to find x, we don't actually have any angle pairs to go off of. Like here, we don't know what angle F is. Here, we don't know what angle E is. And then we know what 93 is, but we don't actually know the opposite side. So if we don't know a side and its opposite, or an angle and its opposite side, then we would use the law of cosines. And there's actually a case where you might have to do two laws, both of them. So we'll go over that in the next video. But make sure, if you haven't looked at the previous video on the law of sines, that you also check that out.